In this video, we will introduce CloudVision, an advanced Arista platform for network automation and operation tasks. CloudVision is the front-end platform for an Arista-based networking solution, providing features such as network provisioning and configuration management, network monitoring and analytics, services integration. CloudVision is made up of two main components, CloudVision Portal and CloudVision Exchange. CloudVision Portal provides access to CloudVision via Web GUI, supports services using CloudVision engines and databases, and provides all the backend functionalities. CloudVision Exchange is a virtualized version of Arista EOS, providing the control plane for overlay services and integration with external controllers. EOS is the Arista operating system. It's present on all Arista switches and network appliances. It is based on a full Fedora core Linux and is characterized by the NetDB, a common repository providing separation between services and their status information. Let's take a closer look at EOS and the NetDB concept. In this picture, we have one Arista switch with its EOS operating system running on top. We can see the Linux core, the various processes running on the switch, and the NetDB repository providing both the processes status and their configuration. In a network environment, we would have multiple switches, each one with their own instance of EOS and their own copy of the NetDB. In a traditional environment, the status of our network would be available by constantly polling the switches individually. With CloudVision, all switches will publish the copy of their internal NetDB to the external collector inside CloudVision engine, maintaining its global database and providing a real-time status of the network. Let's see an example of integration to the underlying network and how CloudVision can help from this point of view. In this slide, we can see a network infrastructure composed of Arista switches under the management and control of CloudVision. There is a clear distinction of the network layer from the applications running on top to control and monitor the network. Instead of having these applications communicating directly with each and every appliance in the network, we would have CloudVision put in the middle to bridge the network infrastructure and these higher level applications. Once the applications communicate their intentions or requests to CloudVision, CloudVision would then diffuse this information or configuration requirements to the rest of the infrastructure. This is how we would achieve scaling efficiency, with applications having to interface with one single point of contact via known APIs, and CloudVision taking care of the details of the network infrastructure using specific communication protocols. NetDB plays a fundamental role in network automation. Let's now see how this concept can provide an advantage with automated deployments. We described how NetDB not only reflects the status of the platform, but also provides configuration information to every process. This allows CloudVision to change or supply a new configuration by rewriting the NetDB on the remote appliance. The advantage of this approach is that CloudVision only has to communicate with a single process on the remote switch, rather than with every single agent running on that box. In addition, by reading the status of the NetDB at the remote ends, CloudVision can obtain full assurance of the new configuration being successfully applied. Let's review the change control mechanism integrated in CloudVision. Every operation performed by CloudVision on the network is associated to a task. For a task to be performed, it has to be embedded inside a change request. And for a change request to be executed, there has to be a validation process. The change validation process is performed by a change management team, and it can be requested via ServiceNow. Once the confirmation is received, the change request can be executed. If they are present, pre- and post-validation tasks can also be carried out automatically by CloudVision. After the execution, the configuration change and the validation tests are reviewed. If necessary, a rollback can be called and CloudVision will automatically proceed to the restoration of the previous network setup. Services insertion. One of the challenges of the leaf-spine data center topology is how to integrate external services such as firewalls and load balancers. With the services integration approach called macro-segmentation, traffic can be directed towards the specific network appliances from anywhere in the network and with minimal effort. Plus, application policies are not stored inside the network, but they're pulled by CloudVision and instantiated to the network switches automatically. Telemetry and analytics. The power of EOS and NetDB is to provide a continuous stream of information and real-time updates. These asynchronous updates are fed to CloudVision and are stored by the CloudVision analytic engine and later reviewed to provide interpretation for real-time monitoring, historical review, and predictive analytics. CloudVision brings multiple functionalities into the network, and it can be used both independently or interconnected to existing platforms, providing a single integration point to overlay controllers and orchestrators. For those realities that are new to network automation and are looking for a turnkey solution for automated deployment and configuration management, CloudVision is an easily deployable and immediately functional product. For organizations looking to expand their existing orchestration platform, CloudVision provides the missing link, hiding the network complexities and details behind a single point of connection while supporting multiple open standards and powerful APIs.